Here's an interesting question on straight line graphs. It looks rather simple, but there is a hidden fact involved that we need to notice it to be able to find the final answer. So let's go ahead. ABCD is a rectangle, so let's highlight that. A, E, and B are points on the straight line L with equation x plus 2y equal to 12. A and D are points on the straight line M. So as we can see here, it's already on the diagram. AE equal to EB. So that is equal to that, which makes E the midpoint of AB. So find an equation for M is what we're required to find. Okay. So since we're dealing with straight line graphs, we need to remember this famous equation, y equals mx plus c. It's actually a formula. So m is the gradient, c is the y-intercept, as you may already know. So we've been given the equation of L, so we need to use that to find the gradient of M. We know that they're perpendicular to each other since this is a rectangle. Line L is x plus 2y equal to 12. So 2y is equal to 12 minus x. So y is equal to, you can write it as 6 minus half x or negative half x plus 6 in the form y equals mx plus c. So that means the gradient of L is negative half. So that means the gradient of M must be opposite reciprocal to that. Since, let's write that here, perpendicular lines have opposite reciprocal gradients, or the product of their gradient is equal to negative 1. So we need to remember that. So we can either divide negative 1 by the gradient of line L to be able to find the gradient of the second line, which is line M, or we can just do negative a half opposite of that. We'll get rid of the sign, which is a half, and then the reciprocal of that would flip it, so 2 over 1, which is 2. So this is the gradient of line M, and we need a point. So right now we have 2x plus c. We need a point to be able to find the value of c. So we have to substitute the x and y of that point into this equation to then be able to find the value of c. We don't have that here right now, so I don't have any information about any point on line M. So that's really the tricky situation here. To be able to then solve this, so we need to use this fact that E is the midpoint of line AB. So kind of we need to solve it in a staircase way. So whatever this is going to the left, then this will be going to the left to get to A. Whatever is going up to get to E, then we need to go up to get to A. Right, so the coordinates of B, we know the y coordinate is going to be 0, since it's on the x-axis. We know the coordinates of E, which is 0, 6, as it's the y-intercept of line L. So we know the y-coordinate of A already, because this is going 6 up, so they must be going 6 more, so that must be something 12. And then to be able to find the x-coordinate of A, we can either put the y-coordinate into, since it's on L, we can put the y-coordinate of A into line L and find the x-coordinate, or we can find the x-coordinate of B and then do the same thing. So I'm going to use B actually, so using line L, so that would be 0, so I'm putting 0 into here. So negative a half, so negative 6 equals negative a half x. So that means x is equal to times by 2, negative 12, so it's 12. Okay, so that's the y coordinate, that's the x coordinate of B. Now, doing the same thing, so I need to go, if that's 12 away, so I need to go 12 that way, so that's negative 12 then for this value here. Now, going back to here, so to complete our equation for M, we're going to use point A. So it becomes point A's got negative 12, 12, the coordinates, and line M becomes equals to 2 multiplied by the x coordinate of A, which is negative 12, plus C. So 12 equals negative 24 plus C. Therefore C is 36. And then finally, equation of M is equal, well, it will be y equals to 2x plus 36. Hopefully that made more sense and gave a bit of clarity.